Welcome to another Ziva Math video. In this video, we'll be exploring the laws of exponents. You might also hear this referred to as the rules of exponents. The product of powers law states that when multiplying expressions with the same base, you keep the base and you add the exponents. So if we have a to the m power times a to the n power, we keep that base a and we add the exponents m plus n. So how does that work with an example? Here we have b to the third power times b to the eighth power. So our rule says that we keep the base b and we add the exponents. So we would have 3 plus 8. And when we add the exponents, we get b to the 11th power. We can also do this with numerical examples as well. If we have 4 squared times 4 to the third power, well, we have the same base of 4, so our rule is to keep the base and they add the exponents, 2 plus 3. So this equals 4 to the fifth power, and 4 to the fifth power is equal to 1024. When we have negative exponents, the rule is to take the reciprocal of the base and multiply it by itself n times. So if we have a base of a, the reciprocal is 1 over a, and the exponent had been negative n, but we're going to keep the n part for our exponent, so 1 over a to the n power. For x to the negative 7 power, our rule is to take the reciprocal of the base. So our base of x has a reciprocal of 1 over x, and we're going to multiply that by itself n times. So n is 7, so we'll have 1 over x to the 7th power. For 2 to the negative third power, our base is 2, so we're taking the reciprocal of the base. So the reciprocal of 2 is 1/2, and n is 3, so we'll have 2 to the third power. So 1 over 2 to the third power is equal to 1 over 8, because 2 to the third power is 8. So 2 to the negative third power is equal to 1/8. The quotient of powers rule says that when dividing expressions with the same base, you subtract the exponent in the denominator from the exponent in the numerator. So if we have a to the m power over a to the n power, that's going to equal the base a, and then we subtract our exponents, so m minus n. Let's take a look at some additional examples. If we have y to the fourth power over y to the second power, well, we're going to keep that base y, and the rule states that we're going to subtract the exponent in the denominator from the exponent in the numerator. So that will be 4 minus 2. And 4 minus 2 is 2, so our answer is y to the second power, or y squared. If we have y squared over y to the fourth, or y squared divided by y to the fourth, we have the same base y, and our rule is to subtract the exponents. Here, we're going to have 2 minus 4. This will equal y to the negative 2 power, because 2 minus 4 is negative 2. And when we have a negative exponent, remember we take the reciprocal and we keep the powers, so 1 over y squared. We can also look at this rule with numerical examples as well. 2 to the fifth power divided by 2 to the third power. We have the same base 2, then we'll be subtracting exponents. 5 minus 3, and so that's going to equal 2 squared, and 2 squared is equal to 4. The power of a power rule says that when you have a base raised to a power raised to another power, then you keep the base and you multiply the two exponents. So if we have a to the m raised to the n power, we keep the base a and we multiply the exponents m times n. So if we have x squared raised to the fifth power, Then we're going to keep the base x, and we're going to multiply our two exponents. So 2 times 5, and 2 times 5 is 10. So x squared raised to the fifth power is x to the 10th power. If we have 3 squared raised to the fourth power, then we're going to keep our base of 3, and we will multiply our two exponents. So 2 times 4. This gives us 3 to the 8th power, because 2 times 4 equals 8. And 3 to the 8th power is equal to 6,561. And the rule for exponents of 0. Any number raised to the power of 0 is equal to 1, whether that's a to the 0 power or 3 to the 0 power. It's going to equal 1. Thank you for watching. Be sure to like this video and subscribe to Ziva Math for more videos.